Hey, welcome back. This is now 5.4, polynomials and several variables. So instead of just having x's or r's or n's or b's, we'll have x's and y's and r's and t's and all that jazz mixed together. Okay, so the first couple of problems you're just doing evaluation. So it's plug and chug basically. So problem 1. Let x equal 2 and y equal -6. In our expression, x squared plus 2x, y plus y squared. So wherever you see x, you're going to put 2. So I'll have 2 squared plus 2 times 2. And wherever you see y, you're going to put a -6 times -6 plus parentheses -6 squared. Okay, and then you simplify. So 2 times 2 is 4 plus 2 times -6. That'll be minus 24. And then -6 squared, negative times negative is positive. 6 times 6 is 36. And then 4 minus 24 is -20. -20 plus 36 is 16. So you're just plugging and chugging. Okay. Same business here. We'll do one more plug and chug. So number 3. So we have 2x squared y minus 3y plus 6. What the heck are the variables? So let x be 4 and let y be -3. Okay, great. So it'll be 2 times 4 squared times -3 minus 3 times -3 plus 6. Okay, so you just order of operations, PEMDAS, right? So 2 times 4 squared is 16, and then times -3. Minus 3 times -3 plus 6. And then we can start multiplying. So 16 times 6, 6 carry 3, that would be -96. Negative times negative is positive 9 plus 6. So that would be -81, I believe. Okay, now we have some definitions to deal with. So there's coefficients and degrees. So problem 4, x cubed y cubed minus 4x cubed y the 7th plus 7y minus 8. Okay. First, they want you to chop it up into 4 parts. So look at x cubed y cubed. They want to know the coefficient. So the coefficient is the number in front of x cubed, y cubed. So the number is just 1. If you don't see anything, just put 1. So the coefficient is 1. And then the degree, you might think it's, well, 3 or something like that, right? You just look for the exponents. But in this case, because there's 2 exponents, what you have to do is add them together. Okay, so the degree in this case will be actually 6. Okay, so that's the first guy. -4x cubed y to the 7th. Okay, so here the coefficient is -4. And then the degree, you add the exponents, right? So 7 plus 3 is 10. Then we have our next term, 7y. So the coefficient there is going to be 7. And then the degree is just 1. So if you don't see anything, put a 1 there. And then the last guy, -8. It's kind of weird that the coefficient is just itself. Right? There's no variable, so you just put -8. And then the degree, if you don't see a variable, you'll just put 0. Right? Okay, so they'll want you to chug through each one of those. So the first term, the coefficient 1, degree 6. And then -410. Oops. 410. Okay. And then the next guy, 7,1. And then the next guy, -8,0. Use the tab button to go from blank to blank. And now the overall degree of the polynomial. So what you're doing is kind of looking at all of the different degrees, and you'll choose the one that's the biggest. Okay? So you have 6, 1, 10, and 0. So the degree of the overall polynomial is 10. So just take the biggest number And whoops. 10. Okay. Okay. All right, now we're on to adding and subtracting polynomials again. It works the same way as before. So to add polynomials, you're just going to drop the parentheses and combine like terms. Okay. So for like terms, if I have 3x squared y and then 5x squared y cubed, those are not like terms. The exponents on both variables need to be the same. So if I had 3x squared y and then 5x squared y, those would be the same. I could add those together and get 8x squared y's. But it needs to have all the same variables with the same exponents for you to add them together. Okay? Okay, so let's look at 5. I'm going to automatically just drop the parentheses for addition. That you could do that. And then I'm going to combine any like terms. If there, sometimes there's not, not a lot to combine. Here, though, I can 8 plus 10 of those is 18x squared y's. And then negative 5 minus 6 of those, negative 11 xy's. Okay, so it's pretty simple, I hope. X squared minus 11 xy. Okay, how many mistakes did I make this time? 8x squared y. That's my y. Okay. Freshman mistake. There's a y there. Sorry about that. And more of the same. Let's try number 7. So I have 5x to the 4th y squared minus 3x squared y squared plus 3xy plus, let's just write that as a minus. So then minus 8x to the 4th y squared minus 5x squared y minus 9xy. Okay. So x4 y squares, there's one, slightly minus 3 of them. And then x squared y squares, well, there's only that guy, 3x squared y squared. If we were going in descending order, I'd have to go to the x squared y right here. So let me put that one next. But I don't think they really care if it's in descending order in this case, in these problems. And then the last one, the xy terms, so minus 6xy. So negative 3x to the 4th y squared. Let's put it out of order, see how the computer acts. X squared y, and then minus 3x squared y squared, and then minus 6xy. Yay. Yeah, so it doesn't care about the order. All right, so next then are subtraction problems. So for subtraction, you first need to distribute the negative. Okay. Then you can drop the parentheses and combine like terms. Okie dokie. So handle number 8. Let's try number 9. Of course, they're going to throw some fractions and all kinds of crazy stuff at you. Minus 10x cubed y plus 4y minus 11x to the 4th y squared plus 11x cubed y plus 5y plus 7x. Okay, go ahead and drop parentheses and distribute. Squared minus 10x cubed y plus 4y. Then we have minus 11x to the 4th y squared minus 11x cubed y minus 5y minus 7x. Okay. And then, okay, x 4th y squares. There's negative 4 of them. X cubed y's, so negative 21 of those. and then y terms, looks like just negative one of those, and then finally negative 7x's. Okay. So negative 4x to the fourth y squared minus 21x cubed y, whoops, cubed y minus y minus 7x. Uh-oh. Oh, I put a double negative in there. Okay, more distribution. Oh, and then we have the vertical alignment for addition. It's no big deal, you just add column-wise. And then subtraction versions of vertical addition. So, okay, so let's do number 11. So I have 4x squared y squared minus 6xy squared plus 5y squared plus negative 10x squared y squared plus 9xy squared minus y squared. So it's pretty simple again, you just add column-wise. So 4x squared y squared minus 10x squared y squared is minus 6x squared y squared. Negative 6xy squared plus 9xy squared is 3xy squared. 5y squared minus y squared is plus 4y squared. So I'll put that in there. Negative 6x squared y squared plus 3xy squared plus 4y squared. What did I do? I put a t in there. So the subtraction version, so you just have to distribute that negative. So I have 4a squared b to the fourth minus 3ab squared plus 5ab minus negative 9a squared b to the fourth minus 8ab squared minus ab. Okay. So if you want to kind of just distribute in your head, 4a squared b to the fourth minus negative 9a squared b to the fourth is really 4a squared b to the fourth plus 9a squared b to the fourth. So that'll give you 13a squared b to the fourth. Then negative 3ab squared minus negative 8ab squared is the same as negative 3ab squared plus 8ab squared. That will give you plus 5ab squared. And then finally 5ab minus negative ab is 5ab plus ab, which will be 6ab's. So I should get 13a squared b to the fourth plus 5ab squared plus 6ab. Okay, and then this is kind of a story problem. Subtract 7x minus 4y from the sum of 12x plus 12y and negative 25x plus 15y. So first you add the two polynomials, 12x plus 12y and negative 25x plus 15y. Add those together. But then you subtract this polynomial away, 7x minus 4y. Subtract from means kind of reverse the order, right? Okay, so adding the first two polynomials, 12x minus 25x is negative 13x. 12y plus 15y is plus 27y. Then I'll distribute this negative, minus 7x plus 4y. So it'll be negative 20x plus 31y. Negative 20x plus 31y. Okay, and now we're on to multiplying monomial by monomial. So you'll first multiply out the constants, and then multiply the variables. And for variable, when you have like bases, you are adding exponents. Okay, so number 14, we have 11x squared y times 7x squared y cubed. Okay. 7 times 11 is 77, and then x squared times x squared, add the exponents for x to the fourth. Y, if you don't see an exponent, it's 1. So y to the 1 plus 3 is 4. Again, use that caret key for exponents. It's above the 6. So you hit shift and then 6, and it gives you the exponent, rather than to go down and hit the little button for exponent. It's too much work. Same jazz here. This multiply the constant, so that'd be negative 12, and then the variables x to the 7 plus 4 is 11. And then y to the 7 plus 4 again is 11. Okay, so hopefully those are pretty simple. Now we're on to monomial times binomial or polynomial. And what it is basically just distribute, and then it's monomial times monomial. Okay, so number 16, we have 2xy times 6x plus 3y. So you just distribute 2xy times 6x plus 2xy times 3y, and then you just multiply monomial times monomial. So you're multiply the constants, multiply the variables by adding exponents. So you'll have 12x, and of course if you don't see an exponent, you put 1 there. So x to the 1 plus 1 is 2y, plus 2 times 3 is 6, x times y to the 1 plus 1 is 2. More of the same. Let's see if we can find one that's a bit harder. Let's try, I guess, 18. So I have 5ab squared times 10a squared b cubed plus 6ab. Let's see if we could just do this kind of without having to write out the monomials. So I'll have 5ab squared times 10a squared b cubed. So 5 times 10 is 50. And then a to the 1 plus 2 power is 3. And then b to the 2 plus 3 is 5. Plus 5 times 6 is 30. And then a to the 1 plus 1 is a squared. B to the 2 times b to the first is b to the third. More distribution. Okay, and now we're on to poly times poly. This is at bino times bino. FOIL, right? But you could always think of it as kind of a double distribution. Those are equivalent. FOIL and doubly distributing is the same. So basically just poly times poly. If you please allow me to write. There you go. Okay, there we go. So poly times poly. So 20, we have x plus 7y times 5x plus 3y. And again, it's just double distribution, right? So x times 5x is going to be 5x squared. X times 3y is going to be 3xy. 7y times 5y is going to be 35xy. And then 7y times 3y will be 21y squared. Combining like terms, 5x squared plus 38xy plus 21y squared. Okay, more of foiling. And now they're officially saying use the FOIL method. Let's do one FOIL before we move. 22 to special products, so it will be next. 4xy minus 5. Okay, so I'll do it in all of its glory this time. 2xy times 4xy plus 2xy times negative 5. Those are the first and the outer. Plus 1 times 4xy plus 1 times negative 5. Okay, so this will give me 8x squared y squared minus 10xy plus 4xy minus 5. And then I can combine like terms, right? Those two guys. This will be 8x squared y squared minus 6xy minus 5. Okay, so now we're on the special products. Remember, for this kind of problem, xy minus 2, you have to FOIL it squared. So it's really xy minus 2 times xy minus 2, and you have to FOIL it. So you'll have xy times xy, xy times negative 2, negative 2 times xy, and then negative 2 times negative 2, multiplying out. So that would be x squared y squared minus 2xy minus 2xy plus 4. So that'll be x squared y squared minus 4xy plus 4. Okay. Oh, same spiel there, same spiel here. I guess we'll try 26. X to the 5th minus 3y to the 7th squared. Again, you have to FOIL. X to the 5th minus 3y to the 7th times x to the 5th minus 3y to the 7th. Okay, so you have x to the 5th times x to the 5th. You add the exponents, right? So it'll be x to the 10th. X to the 5th times negative 3y to the 7th is going to give you negative 3x to the 5th y to the 7th. So we want the variables in alphabetical order. So if you had a z, you would put it last, right? Here I have an x and a y, so I put the x before the y. Then we have negative 3y to the 7th times x to the 5th. So I'm going to write it as negative 3, put the x first, and then the y. And then negative times negative is positive. 9y to the 14, just add the exponents. Combine like terms if there are any, and there are. The two middle terms are like terms. To the 10th minus 6x to the 5th, y to the 7th, plus 9y to the 14th. Then we'll probably have the next special form where the inner and outer terms cancel out. Okay, so we'll try 28. AB plus 5 times AB minus 5. Okay, so you could still just FOIL, and you'll note that the inner and outers cancel. So AB times AB plus AB times negative 5, then the inner plus 5 times AB, and the last plus 5 times negative 5. Okay, AB times AB is a squared b squared minus 5AB plus 5AB, and then minus 25. Those guys are gone, so you just end up with the first and the last squared. A squared b squared minus 25. More special forms. Inner and outers are going to cancel. So let's try 30. 8a squared b plus a times 8a squared b minus a. So first, we're going to be 64a to the 4th b squared, outer, minus 8a cubed b inner, plus 8a cubed b, and then last, minus a squared. So the inner and outer are gone. 64a to the 4th b squared minus a squared. More cancellation in the inner. But this one's a little different. So maybe it looks like there's going to be cancellation, but there's not. What do we have? A to the 5th plus b to the 5th times a to the 7th minus b to the 7th. Okay, so the first a to the 5th times a to the 7th, you add the exponents. So you get a to the 12th. So first, then the outer, that'll be minus a to the 5th times b to the 7th. Then the inner. Put it in alphabetical order, so I put the a to the 7th first, and then b to the 5th, then the last, minus b to the 5 plus 7 is 12. So yeah, there's nothing to combine here. It's just, it is what it is. It's very depressing. A to the 12th minus a to the 5th, b to the 7th, plus a to the 7th, b to the 5th, minus b to the 12th. And of course I put a double negative in there. Okay, so you're doubling up on your distribution here. Monomial times trinomial cases. Let's try 34. So I have x minus y times x squared minus 9xy plus y squared. Okay, so first, like that. So x times x squared plus x times negative 9xy plus x times y squared. And then distribute this other dude. So plus negative y times x squared plus negative y times negative 9xy plus negative y times y squared. Multiply out. X times x squared, add the exponents. So x to the 2 plus 1 is 3 minus 9. X times x is x squared. Add the exponents. 1 plus 1 is 2. And y plus xy squared minus x squared y. Put it in alphabetical order, please. Negative is positive. 9x y times y is y squared. And then minus y times y squared. 1 plus 2 is 3 on the exponent. Combine any like terms if there are any. So I have x cubed, x squared y's. Okay, so there's negative 10 x squared y's. And then xy squares. So there's plus 10 xy squares. And then finally minus the y cubed. Okay, so it's just a bunch of distributions, 6 distributions, and then combine like terms. Another with extra distributions. This one is, just 37 x squared y to the 4th minus 8 minus 8 squared. So it seems like this is just practice now at this point. X squared y to the 4th minus 8 times x squared y to the 4th minus 8. Okay, so first outer and last, x squared y to the fourth times x squared y to the fourth. Let's just multiply that out right now, right? So x to the 2 plus 2 is 4, y to the 4 plus 4 is 8. First outer, that'll be minus 8x squared y to the fourth, inner, minus 8x squared y to the fourth, and then last, plus 64. So I'm going to get x to the fourth, y to the eighth, minus 16x squared y to the fourth, and then plus 64. Fourth, y to the eighth, minus 16x squared to the fourth, plus 64. So we should be getting plenty of practice, which is good. Oh, and then these are kind of tricky. Okay. So you can literally sit there and distribute, and you'd have 9 terms, but there's kind of a shortcut if you remember the a squared minus b squared formula. So again, if you have a plus b times a minus b, the inner and outer terms are going to cancel. Okay, so you'd just be left with a squared minus b squared. So if you can rewrite the given expression in that way, you can kind of quickly get to the answer. And that's what you want to do in 38. If you don't like this method, you could just sit there and distribute out 3 times. That'll work as well. But the kind of clever way is to think of it as the a is the x plus y, and the b is the 7. Okay? So when you multiply it out using the formula, you'll get a squared, which is that x plus y, minus the b squared, which is the 7. So 7 squared is 49. Then all you need to do is FOIL out the x plus y squared. So that's x plus y times x plus y. And then that will be first x squared plus outer xy plus inner yx, which is the same as xy. And then last plus y squared. Y times y is y squared. And then you could combine like terms, and you get x squared plus 2xy plus y squared minus 49. But that being said, you can always, do it the hard way, triply distribute. Here's another convert geometry into algebra. So just multiply the sides of the. This one's even worse. Write a polynomial in 2 variables that describes the total area of the shaded region. Express the polynomial as a sum or difference of terms. Okie dokie. So this is kind of a what is it? It's kind of a donut hole type problem. Number 40 here. So you have this box here that has sides x and x, and then we could cut this up into a bunch of y's, and then this also up into 2 y's. It's not drawn to scale, but there it is. Oh, it looks like a flag. All right, I guess they want it like this. And so what's going on? Well, again, to find the kind of area of the shaded region, this stuff, what you're going to do is find the area of the big box, right? And then subtract away the area of the stuff you don't want, the whole, I guess you get to go. So the big box, the top distance is x plus y plus y plus y, so 4 y's. And then the side distance looks like it's just x plus y, which is 2 y's. Okay. So the area of the big box is going to be x plus 4y times x plus 2y. And then the area of the little box, well, that's easy. It's just length times width, and in each case, it's just x. So it'll be minus x times x, which is x squared. Okay. So FOIL out x times x is x squared. X times 2y is plus 2xy. and then 4y times x is plus 4xy, and then 4y times 2y is plus 8y squared, and then minus the x squared. The x squares will cancel, and it looks like you get 2xy plus 4xy is 6xy's plus 8y squared. And let's see if that works. And, was there 5 of them? 1, 2, 3. There it is. I missed one of them. Crap. There's an extra. I hit the button on top of it. Okay, so there's an extra wedge right here. Sorry about that. So it's actually 5 y's, not 4. Let's spruce things up a little bit. Okay, so it'll be 5y. And so this guy and this guy are wrong. Okay, so 5y times x is 5xy, and then 5y times 2y is 10y squared. The x's cancel, 5xy plus 2xy is 7xy's, and then plus the 10y squared. Sorry about that. My sight is going as I get older. It's a bummer. All right, and then kind of the more challenging problems here at the end. Let's see if there's. So you definitely want to use that difference, this a plus b times a minus b formula to pull these off. So again, if you have a plus b times a minus b, all you have to do is take a and square it, and then subtract away b squared. Okay, so in our case, we have x cubed y cubed plus 1 times x cubed y cubed minus 1, and then we square all that. So on the inside here, that's a difference of squares. So you can just go x cubed y cubed squared, which is basically just x cubed y cubed times x cubed y cubed, which is x to the 6, y to the 6, minus b squared, and b is just 1. 1 squared is 1. Then you could expand this and FOIL. And so foiling x to the 6, y is 6 times x to the 6, y is 6 is going to give you x to the 12th, y to the 12th, and then minus x6, y6, and then another minus x6, y6, and negative 1 times negative 1 is plus 1. And then you combine like terms, so you get x12, y12, minus 2x6, y6, plus 1. And that should do it. Okay. Number 42 is another one where you could use that formula, a squared minus b squared formula. It's not clear at first. I mean, you could sit there and literally, multiply out 4 binomials, which isn't a bad thing to do, but it's a little quicker if you pull this trick. So, I mean, literally, what is it? It's xy plus 2 times xy plus 2 times xy minus 2 times xy minus 2. Okay. But if you use the a plus b, a minus b formula and kind of group those expressions together like this, and then group these other two together like this, then you can multiply those out and you get, a squared, which is xy squared, which is x squared y squared, minus b squared, minus 4. And then this will be the same thing. So you'll just have x squared y squared minus 4, and then you could FOIL that out and you'll have your answer. Okay, so foiling it out, you get x 4, y4, that's the first. Then the outer, minus 4x squared, y squared. Then the inner, minus 4x squared, y squared. And last, plus 16. Okay. So I'll have x to the fourth, y to the fourth, minus 8x squared, y squared, and then plus 16. And then that'll do it. And of course, I put a double negative in there. Now I have no negative. Okay, let me just show you that same problem, but the long way, the brute force kind of approach, and how would that work? So xy plus 2 squared is xy plus 2 times xy plus 2. And then xy minus 2 squared is xy minus 2 times xy minus 2. So if I didn't use that, maybe you don't understand the formula, right? What would I do then? Well, it's going to be long. So first you have to FOIL this guy out. So xy times xy is x squared y squared. And then xy times 2 is plus 2xy. And then the inner plus 2xy. And then the last plus 4. Okay. So this will be x squared y squared plus 4xy plus 4. And then you have xy minus 2 times xy minus 2. Okay. And you could choose to multiply any two numbers that you want. You can only do 2 at a time, though. So I'm going to multiply those two out. So we'll have x squared y squared plus 4xy plus 4. And then multiplying those guys, the first, you get x squared y squared, the outer, minus 2xy, the inner, minus 2xy, and then the last, plus 4. And then simplify that. Okay. And then you have triple distribution, right? So x squared y squared times x squared y squared is x fourth y fourth. X squared y squared times negative 4xy is negative 4x cubed y cubed. X squared y squared times 4 plus 4x squared y squared. Okay. And then the next three, I'm going to go 4xy times x squared y squared. That's going to give me plus 4x cubed y cubed. And then 4xy times negative 4xy is negative 16x squared y squared. And then 4xy times 4 is plus 16xy. And then the last one, plus 4x squared y squared. And then minus 16xy. And then plus 16. And if you see what I did, I kind of lined them all up in that vertical way. So I can add column-wise, and it's a little quicker. X to the fourth, y to the fourth. These guys cancel. And then I have 4, 8, minus 16, so minus 8x squares, y squares. And these cancel. And then you get plus 16. Okay, which is the same answer we got. But there's alternate ways to do it, just depending on kind of your specific tool set. So if you don't get the a squared minus b squared, you're going to have to sit there and kind of multiply the heck out of it, right? So in this one, you would have to first multiply out these two inner terms and then square. But I mean, that's the same kind of what I did there anyways. It's just if you can't do the formula, it'll end up being, x to the 6, y to the 6, then the outer minus x cubed, y cubed, and then the inner plus x cubed, y cubed, and then the last minus 1. And then these two canceled, and then you get to the next step. And then this one up here, you would have to do if you didn't do the a squared minus b squared, you have to triple distribute, right? So you get x squared plus xy minus 7x, and then with the y, you would get xy plus 7y, and then minus xy plus y squared minus 7y, and then with the last one, 7x plus 7y minus 49, and then adding those together, x squared plus 2xy. These 7x's cancel, there's a plus y squared, and then these cancel, and then there's a 49, so you get the same thing. But, you know, if you got the formula down, then it's a little easier. Let's try 43. So p minus q plus r times p plus q plus r. Okay, so again, you could think of this as a minus b times a plus b. And in this case, it'll be p minus q plus r times p plus q plus r. Okay, so that would be the first squared, a squared, minus the last squared, q plus r squared. And then that would be p squared minus q plus r times q plus r. And that would be p squared minus q squared plus qr plus qr plus r squared. Combine like terms. So I get q squared plus 2qr plus r squared. And then distribute the negative. Q squared minus q squared minus 2qr minus r squared. Right, and that would do it. P squared minus q squared minus 2qr minus r squared. You know, and if you didn't get that, you just have to literally sit there and multiply them all out. So you'd have p minus q plus r times p plus q plus r. And first you distribute, so you have to distribute first. So p minus q minus r times p plus q plus r. And then you have this triple distribution, right? So p times p is p squared, plus p times q, plus p times r, and then distribute the minus q, so you minus p times q right there, and then minus q squared, and then minus q times r, and then the r portion, so minus r times p, or p times r rather, minus q times r minus r squared, and then that would be p squared. The PQs will go. PR and RP are the same. They're additive opposites, so they'll go. And then you have minus Q squared, and then there's 2 QRs, minus 2 QRs, and then minus R squared. And you see you get the same thing as what we got originally using the difference, the formula. A plus B, A minus B is A squared minus B squared. But it's up to you, whichever way you want to do it. Probably in your shoes, I would just do brute force. And it would give you a lot of practice doing these problems. And this stuff kind of has to be, you kind of have to be really good at it later on if you keep on taking math. So not a bad idea to sit there and chug through it and just kind of get it out of the way so you can go on to bigger, better things. Okay? So anyways, I hope that helps as usual, and we shall see you next time.